Alright, so today we're going to go over graphing exponential functions. And we have two main types. We have growth, which means that the term being raised to the exponent, so the number being raised to the exponent, which in this case is x, is greater than 1, and it's going to move away from the x-axis. The second type is decay, which means the number that's being raised to the exponent, the number that's being raised to an x, is less than 1. So it's between 0 and 1. And it's getting closer to the x value. Now notice that these functions, they are never going to cross this line, which means they both have horizontal asymptotes at y equals 0. Both of their domains, they go on for infinite to the left and the right, is from negative infinity to positive infinity. And the range for all of these functions, both of these, is from our horizontal asymptote of 0 to infinity. Now, what's going to change depending on the function is your horizontal asymptote will change, your range will change, but your domain is always going to be negative infinity to positive infinity. Alright, so let's look at our first one. Let's look at y equals 3 to the x. So basically, there's not really a shortcut for these like there was for the other problems. It's easier just to do this the long way. So what we're going to do is we're going to make a table of values, and we're basically going to pick these 5 points. -2, -1, 0, 1, and 2. And we're always going to pick these points unless our function moves left and right. So what we do is you're just going to plug it in for x. So this first one will be 3 to the -2nd power, and you can stick this in your calculator or do this by hand. Negative exponents, move it to the denominator. This is 3 squared, which is 1/9. Plug in -1, so this is 3 to the -1 power, so this is 1/3. 3 to the 0 power, anything to the 0 power is 1. 3 to the 1st power is 3, and 3 to the 2nd power is 9. Now, this number that we're adding out here, this is your horizontal asymptote. So my horizontal asymptote is at y equals 0. So when I go to the next slide, I'll have a graph on there. Alright, so my horizontal asymptote here is at 0. So this would be in a highlighter, if you have a highlighter. And then I'm going to plot my points. So I need to go back to my other screen to be able to view this. -2, 1/9. -1/3. 1. 3 to the 1st was 3, and 2nd was 9. 3, 4, 5, 6, 7, 8. Make that high enough. 9. Remember, your function is not going to cross your asymptote, it's just going to get really, really close. Alright, so your domain, again, for all of these is negative infinity to positive infinity. And my range is my lowest point, my horizontal asymptote at 0, and I'm going up to infinity. Alright, so number 2, f of x equals 1/2 times 5 to the x minus 4. This is a growth because 5 is being raised to the exponent and it's bigger than 1. So I'm going to make my table of values. And again, we're always going to pick this unless it's moving left and right. And what tells you it's moving left and right is with the x. And when we get to 1, I'll show you. You'll see. Alright, so when we plug these in, you can use your calculator to plug them in. It might be easier for some of these convoluted ones. Just make sure you put parentheses around your exponent as well. Okay, and you can even put it around the first one too if you want. So when we plug in 2, 1/2 times 5 to the -2 minus 4. Stick this in your calculator. You could try and do it by hand as well, and you should get... And this should equal, I get -3.98. When I plug in -1, I get, again, -3.9. plug in 0, I get negative 3.5. Plug in 1, I get negative 1.5. And plug in 2, I get 8.5. Alright, so make sure, pause this video, check, make sure you know how to, you can stick it in your calculator. Alright, this minus 4 is telling me that my horizontal asymptote is at y equals negative 4. That's going to be my boundary line that I don't cross. Okay, so on your graph in highlighter at negative 4, hopefully yours is a little bit straighter than mine. And then I plot my points. So negative 2, negative 3.98. These are going to be super duper close to each other. Negative 3.5, negative 1.5, and then 8.5. You can connect your points. Alright. Your domain is negative infinity to positive infinity. Your range is from your horizontal asymptote. So here my lowest y value is negative 4. It's going to approach negative 4. And my highest y value is infinity. Alright, notice it's moving away from my horizontal asymptote, away from my x-axis. So that's what makes this a growth. Another way. Alright, so 3y equals negative 3 times 2 raised to the x minus 4 plus 1. So now here's one of the times that we're not going to pick negative 2, negative 1, 0, 1, 2. And the reason is this x minus 4 is telling us to move our graph to the right 4. Because remember, it's opposite whenever it's with the graph, with the x when it's inside the function. Now you could pick negative 2, negative 1, 0, 1, and 2. But remember how on our previous example, like these two were super duper close to each other? That's what's going to happen to all of your points, and you're not going to get much. You want to try and get, by picking these certain points, you're going to get the center of your graph. So, normally, again, we pick negative 2, negative 1, 0, 1, and 2. But now we need to go right 4. So the x values when I go right 4 is going to be 2, 3, 4, 5, and 6. And these are going to be the values that I plug in for x to get my y values. Okay, now again, be very careful when you plug this into your calculator. Make sure you put all of the necessary parentheses. So here, I'm going to put negative 3, 2. And then when you put your exponent in parentheses. Put 2 minus 4 in a parenthesis. And then plus 1. Okay, and you should get for this one a positive 0.25. Try the other ones. Once you have it set up in your calculator, you can just hit the up button and change the numbers that you need to. When you plug in 3, you should get negative 0.5. 4 should give you a negative 2. 5 should give you a negative 5. And 6 should give you a negative 11. So then we're going to go ahead. Your horizontal asymptote here is at y equals 1. So go ahead. We're going to graph at y equals 1. That's a horizontal asymptote. And then we're going to plot the points. So at 2, I have 0.4, or I have 0.25, 1/4. At 3, I have negative 1/2. At 4, we had negative 2. At 5, we had negative 5. And then at 6, we have negative 11, which I can't do on my graph. It's way down there. And then connect your points. Remember, don't cross your horizontal asymptote. Alright, so our domain here is from negative infinity to positive infinity. Remember, your range is your low to high. So looking at this graph, my lowest point, it's going down to negative infinity. My highest point is 1, my horizontal asymptote. So here, when it's going down, you want to put the negative infinity and then your horizontal asymptote. As opposed to when it went up, we put our horizontal asymptote and then positive infinity. Alright, so this one is going to be number 4. This is an exponential decay. And the reason it is a decay is because this 1/3 is what's being raised to the exponent, and it's smaller than 1. So if whatever's being raised to the exponent is smaller than 1, that makes it a decay problem. And notice we're not moving left or right any. The x up here is by itself, so since the x is by itself, we use our standard -2, -1, 0, 1, and 2. And then we stick it in our calculator. So 5 times 1/3 to the -2nd power, and put that -2 in its own parenthesis. So go ahead, see if you can get these table of values. And when you do this, plug in -2, this is going to give 45, which is going to be too big to graph, so we're just not going to worry about that one. When we plug in -1, we get 15, which again is too big to graph, so we don't have to worry about it. Plug in 0, we get 5. Plug in 1, and you get 1.6 repeating. And plug in 2, you get approximately 0.5. Alright. We also have a plus 0 over here. And this 0 is your horizontal asymptote. So let's go over to the graphing part. So my horizontal asymptote is at 0. And then I plot my points. My first two were too large to plot. So I plug, the first one I can actually fit on my graph is the 0, 5. So this one. The 1, 1.6 repeating, approximately right there. And then the 2 is 0.5. So my graph is going to look something like this. It's going to keep getting closer. Remember, this is all the way up at 15, so it's pretty steep on this side. So your domain here, again, these domains are always going to be negative infinity to positive infinity. My range is my low to my high. My lowest, it's approaching 0. I have an arrow going up to infinity. Alright, number 5. Y equals -1/2 raised to the x plus 3 plus 5. Alright, so when I go to make my table, remember my normal x's that I pick are -2, -1, 0, 1, and 2. Now again, you can pick these values, but your numbers, remember previously, they're going to be so close together, or it could be something like how our last one is, they just don't fit on our graph. So what we do is we look at this x plus 3. Now this x plus 3, the plus 3 with the x is telling it that it's going to move left 3. That means I need to take my x values here and move them left 3. So when I move my x values left 3, I'll get -5, -4, -3, -2, and -1. And these are going to be the x values that I plug in to get my y values. Remember, don't be shy about the parentheses. Put parentheses around the exponents, around whatever you're raising it or whatever you're multiplying it to. So I'm going to put -1/2, and then in parentheses, -5 plus 3, and then plus 5. Okay? Make sure you put parentheses around the exponent, especially when you're adding or subtracting to the exponent. Alright, pause the video, see if you can get these values. Make sure you know how to stick them into your calculator, because that's basically what this lesson is almost about. So when we plug in negative 5, you should get out 1. Plugging in negative 4 should give you 3, 4, 4.5, and 4.75. Alright, and then your horizontal asymptote here is at y equals 5. So this is your highlighter line. Let's go over to our graph. We have a horizontal asymptote at 5. So 1, 2, 3, 4, 5. And then we plot our points. At negative 5, we're at 1. Negative 4 is 3. Negative 3 is 4. 4.5. 4.75. And then connect your points. Right, and make sure it does not cross your horizontal asymptote. So your domain for this would be negative infinity to positive infinity. And your range is your low to your high, so this is negative infinity to my horizontal asymptote of 5. Alright, so number 6 is the last one for the notes. I'd actually like you guys to try this one on your own. See how you can do it. So pause the video, see if you can go from start to finish, and then hit play, and I'll just put up the answers. I'm not really going to walk through and explain it. Alright, so pause it now. Alright, so check your points. 94, 22, 4, negative 0.5, and negative 1.625. Notice, just like on the previous one, our first 2 points are too big to graph. That's okay. That's normal. Just graph the points that you can, whether it's 3 points, whether it's 5 points. And your graph should look like this. So your graph should look like this with a domain of negative infinity to positive infinity and a range from negative 2 to infinity. And that's all of the notes that I have. If you still have time left after you've watched these notes, work on your assignments. It's on your page. What's technically is supposed to be due tomorrow, but you can turn it in Thursday because I'll be there if you don't feel comfortable turning it in. Alright. If you have any other questions or need any extra assistance, send me a message to remind, and I'll be able to answer it for you.